A ladder 10 meter long leans against a vertical wall x meter high. The distance between the wall and the foot of the ladder is 2 meters longer than the height of the wall. The question asked is to calculate the value of x. So this is the question. I will attempt to answer this question right now. Solution to this, what I'll do first is to sketch this, is to make a sketch of this question into drawing, to change or translate these statements into drawing. So I have my drawing like this. This is the ladder, which is 10 meter long, ladder 10 meter long, and it leans against a vertical wall. This is the wall, and the wall is x meter high. So this is the length or the height of the wall, x. And in the question it says the distance between the wall and the foot of the ladder. This is the wall, this is the foot of the ladder. So this distance from the wall to the foot of the ladder is 2 meters longer than the height of the wall, and the height of the wall is x. So this distance from the wall to the foot of the ladder is 2 meters longer. So I add 2 to the height of the wall, so it will give me this distance from the foot of the ladder to the wall, 2 meters longer than the height of the wall. So with that I have make my drawing correctly. So let me move ahead and find the height of the wall, which is x. So applying Pythagoras, because this is a right angle triangle, because always the wall is at 90 degrees to the horizontal ground. Always wall is vertically erected on the ground, so this angle is 90. So my triangle is right angle triangle, so I can apply my Pythagoras. So square of 10, the hypotenuse, is equals to square of this side x plus the square of the other side, which is x plus 2. So if I continue expanding this, I have 100 equals to 10 square is 100. This is the x square. The x plus 2 whole squared means x plus 2 times another x plus 2. So I will now next x to expand these two brackets. So expanding the two brackets, I have x square, x times x times 2 is 2x, 2 times x is 2x, 2 times 2 is 4. So I'll collect like terms. This is x squared, this is x squared, this is 2x, this is 2x. So in the end I'm going to have 100 equals to 2x squared. That is x squared plus another x squared is 2x squared. And this 2x plus this 2x give answer 4x. Then I'll copy this. So I continue rearranging this. 4 move to the other side becomes minus, so 100 minus 4 is 96. So I continue. This is a quadratic, so dividing both sides by 2, because 2 can go into each and every term here. So 96 divided by 2 is 48. 2x squared divided by 2 is x squared. 4x divided by 2 is 2x. I have reduced this quadratic to a much simpler one. So I can now move and solve this quadratic. Take this. I'm tempting to factorize this. So 48 move to the other side. I have x squared plus 2x minus 48 equals to 0. So factorizing this correctly, I have x plus 8 into x minus 6. These are the factors, plus 8 and minus 6. So solving this will now give answer x as minus 8 or x as 6. But because this is distance, the x represents distance, the height of the wall, so it can never be negative. So I will discard this, I will take this. So therefore the wall is 6 meters high. So with this I have answered this very question. Let us see the mark distribution of this very question according to the Waec marking scheme. And the first mark is B1 mark, where you denote the length or the distance from the foot of the ladder to the wall as x plus 2, meaning add 2 to the height of the wall. So you have the bonus 1 mark there. For using the Pythagoras, you have the method mark, and for simplifying or trying to solve, you have method 1 mark also. And the final mark is where you have the distance x as 6, you have the accuracy mark. So in total there are 4 marks to this very question according to the marking scheme.